discussing polygons. And as part of our lecture, we're going to have quite a few vocabulary words today. Some of the vocabulary words we're going to cover are congruent, corresponding, consecutive, perimeter, equilateral, equiangular, regular, convex, and concave, just to name a few. And there might be a few that pop up along the way, so let's just pay close attention as we go with our definitions. But these are just some of the ones that we're going to be covering. And before we start discussing these definitions, let's define what a polygon is. Let's define what a polygon is. Okay? A polygon is a closed figure in a plane. We all know what a plane is. So it's a closed figure in a plane formed by connecting line segments endpoint to endpoint, with each segment intersecting with exactly two endpoints. I'm sorry guys, this is a typo. This word should not be there. It's repeating twice. So a polygon is a closed figure in a plane formed by connecting line segments endpoint to endpoint, with each segment intersecting with exactly two endpoints. So let's take a look at a picture of what polygons look like and what some polygons are not. Okay, so here we have some images of polygons. These are all closed figures. They're all in the same plane. Well, this one is enclosed. This one's not closed. Okay. These are all connected by line segments. These are all line segments. Okay. This one is not all connected by line segments. And this line here bending here, that's not a segment because it's bent. Okay. And the line segments are connecting endpoint to endpoint with exactly two endpoints. Well, this right here has right here has two endpoints. This one has two. This one has two. So if you notice, they all the segments connect with two endpoints. This one doesn't. This one has no endpoints. This one doesn't meet the other criteria. And if you notice this one here, right here, we have 1, 2, 3, and 4. We have 4 segments connecting to one endpoint there. And that's why that's not a polygon. That's why that's not a polygon. So we can see what a polygon is, and we can see what a polygon isn't. Now, each line segment of a polygon is called a side. Each segment is called a side. So, if we look here, this is a side, this is a side, this is a side, this is a side, this is a side. These are all sides on my polygons here. Each segment is considered a side. Okay, we can see all those sides there. Okay, and each point where the segments meet is called the vertex. Well, haven't we seen that somewhere before? Yes, we have, when we're talking about angles. So each point where the segments meet, that's actually a point called the vertex. So looking at these pictures here, this would be a vertex, point would be a vertex, that would be a vertex, and that would be a vertex. Looking at the triangle, we would have 3 vertices. That's how you say, that's the plural for vertexes, for a vertex. And if we look here, these are all vertices. So each point where the segments meet is called a vertex. Now, let's talk about our first vocabulary word. Well, not our first, but one of the vocabulary words for the day. And that is consecutive. Write that down. Consecutive. Consecutive means one right after the other. For example, the numbers 1, 2, and 3 are consecutive. The letters A, B, and C are consecutive because they come right after the other. You can also have consecutive even numbers, which would be 2, 4, 6, 8. Notice I said consecutive even numbers. You can even have consecutive odd numbers, 1, 3, 5, 7. But I have to stipulate what consecutive means. If I'm not saying a special consecutive, it's one right after the other. That's what it means. one right after the other. Okay? Now, why do we need to know what consecutive means? Well, because in a polygon, we have some consecutive parts. If we look here at this polygon that has, let me see, how many sides does this polygon have? It has 1, 2, 3, 4, and 5. This polygon has 5 sides. Well, I have consecutive angles. Consecutive angles are angles that come one right after the other. They are consecutive angles that come one right after the other. So I can say that angle A and angle E are consecutive angles. I could also say that angle AE and angle D are consecutive angles. Are angles A and angle C consecutive? Are these two consecutive? No. The answer is no. They are not consecutive angles. Next, we have consecutive vertices. Well, vertices are points that come one right after the other. So E is D, C, E, D, and C are all consecutive. I can even go all the way around the block. Well, I should probably go in alphabetical order. That's probably a little bit better because you're going to see that from most of your polygons. They usually go in alphabetical order. So I would say A, B, C, D, and E are all consecutive in that order. A, B, C, D, and E. They are consecutive in this order. I can even say that A and B are consecutive. But the question now is, are vertices A and C, are they consecutive? No, they are not, because they have B between them. Finally, we have consecutive sides. And just like the other components, they have to be one right after the other. So I would say that segment ED, which is this segment here, and by the way, this is not a congruency mark. I'm not saying that this is congruent to this, but I'm just marking it just to get your attention here. I can say that segment ED is consecutive with segment DC. Notice they have a common endpoint. So segment ED is consecutive with segment DC. Let's take a look here. Is segment ED consecutive with segment CB? Is segment ED consecutive with segment CB? The answer is no, because there is this segment in between them. So we've covered consecutive angles, consecutive vertices, and consecutive sides. Now next, we're just going to talk about polygons in general. And I'm sure you've seen this sometime before. So yeah, if a polygon has 3 sides, it's a triangle, 4 is a quadrilateral, 5 is a pentagon, 6 hexagon, 7 heptagon, 8 octagon, like an octopus, 9 nonagon, 10 decagon, 11 undecagon, and 12 dodecagon. Anything past that, we can just call it an n-gon for now. Okay? Now, let's talk about a special component of polygons, and that is a diagonal. A diagonal. Okay? A diagonal is a line segment that connects 2 vertices that are not consecutive. So let's take a look here at this polygon, and this polygon would be called a quadrilateral. Why? Because it has 4 sides. 1, 2, 3, 4. And according to our list here, anything with 4 sides is called a quadrilateral. Well, here I have my diagonal. My diagonal is touching points vertices D and F. They are not consecutive. D and E are consecutive, E and F are consecutive, but D and F are not consecutive. So, a diagonal is a line segment that connects vertices that are not consecutive. Okay? And of course, we know that my diagonal would be named diagonal line DF. I'm sorry, my mistake, not line, because this is a segment. I'm sorry, didn't mean to confuse you there. Let me take that off. Let's delete that, and let's put the correct. There we go. Segment DF is our diagonal. Now, why are diagonals important? Why do we need to know how to identify them? because now we have special kinds of polygons, which are called convex and concave. We have convex and concave, and they're pretty easy to remember. Let me show you a picture of what they look like. Okay? Here on the left, we have convex polygons. Convex polygons, all the diagonals are inside. In a concave polygon, one or more of the diagonals are on the outside. One or more of the diagonals are on the outside. But you know what? I have a little shortcut for remembering what a concave polygon is. My shortcut is this. Here's a box. Here's a box. Let's pretend for a second that we have a regular cardboard box. And you're walking through your house and you have a cardboard box and you're not looking where you're going. And all of a sudden, you kick the box by mistake. So your box gets caved in. And all of a sudden, your box that used to look like this now looks like that there. That would be a concave. Why? Because it's been kicked in. It went from looking like a regular box and you kicked in the sides. This could have been some type of quadrilateral and they kicked it in. And now it's dented in. Notice the convex ones are all nice and smooth on the outside, while these look like they've been dented. So a concave is pretty much a dented polygon, and since you dent it, you can draw a diagonal on the outside. You can have a diagonal going from two non-consecutive points. Non-consecutive points. Now let's move on to another kind of polygon. But before we do that, let's talk about corresponding. And I'm sorry, we're not actually moving to another polygon now. We're going to be talking about the word corresponding. What does the word corresponding mean? Well, simply enough, it means matching. It means matching. If you remember earlier, we talked about that geometry likes to have things in matching order. And here we're going to have two corresponding images. These are two corresponding images, very similar to the triangles that we talked about earlier. These are corresponding images. Quadrilateral CAMP is congruent to quadrilateral SITE. Now, let's take a look at the letter C here. The letter C is for angle C, right here. Notice that angle C has an angle here and it only has one dash. Well, which one has one dash here? Well, it's angle S. So angle C corresponds or matches angle S. Okay, now we have angle A. Well, which other angle here has two dashes just like angle A does for the angle? Well, it's angle I. So angle A and angle I are corresponding angles. They correspond to each other. They match. Next, what angle corresponds with angle M? Which one has three dashes? Well, we can see here it's angle T. Angle T, they both have three dashes, so they have corresponding angles. They match. And finally, we can see that P corresponds to E. P corresponds to E. Let me color match them here for you. Now, something very important here. Something very important. Notice the order of the letters. Notice the order of the letters in the name. The first one is yellow here. First one is yellow there. Green, green, or CS, AI, AM, MT, PE. The order of the letters from one polygon match the order of the letters from the other one. That's how you know that they're corresponding. Usually, they don't have to even show you a picture. When they put them in the name in that order, you know that each letter from this side matches the other one, just like we did with the triangles. Now, why is that important? Well, let's talk about corresponding sides. Let's talk about corresponding sides. Let's say, for example, I want to mention a segment. Let's say, for example, I want to mention segment CA. Let's say I mention segment CA. Well, what's the corresponding segment for segment CA? What's the corresponding segment for segment CA? Well, notice I'm going from 1 to 2. from 1 to 2. So I have to make sure that when I name my segment, it's also going from 1 to 2. So it would be, corresponding segment would be segment SI. SI. What about, for example, if I had segment TE? Let's say, for example, I had segment TE. Well, what would be corresponding to segment TE? What would be corresponding to segment TE? Well, notice from T to E, I'm going from 3 to 4. From 3 to 4. So 3 dashes to 4 dashes. So I got to make sure that I match that I go from 3 to 4. So it would be segment MP. Segment MP. Now, let's take a look at the name real quick. Notice here, I'm going from C to A here, and I'm going from S to I here. So when they're corresponding, I'm going the same order in the name. Over here, I'm going from T to E. T to E here. So now guess what? I'm going to go from what? From M to P. It's going from M to P. Okay? Let's say, for example, that I went from, oh, I don't know. Let's say I went from C to P. Let's say I was talking about segment CP. Segment CP. What would be corresponding from segment CP? Well, I don't even need to look at the picture. If I'm going from C to P, then I know that I'd be going here. I'd be going from S to E. Well, let's take a look here. C to P is 1 to 4. Well, look at that. S to E is also what? 1 to 4. So the corresponding segment would be segment SE. Segment SE. Okay, so corresponding matching letters is very, very important. And that brings us to a rule. That brings us to a very important rule. And that rule says this. It says, if the polygons are congruent, if the polygons are the same, then the sides and the angles are matching. If the polygons are identical, they're clones, then the sides and the angles are going to be matching. And it also goes this way. If the sides and the angles are matching, if all the sides and all the angles are matching, then the polygons are congruent. Then the polygons are identical. Then they are identical. Okay? Now, let's talk about some special polygons. Let's talk about some special polygons. Okay? The first group of special polygons that we're going to talk about are going to be equilateral polygons. Equilateral polygons. And these are pretty simple. Equa means equal, lateral means side. So in equilateral polygons, all of the sides are equal. All of the sides are equal in equilateral polygons. Next, we have another special group, and those are called equiangular. Equiangular. And if you guess that equiangular means that all the angles are equal, you guessed correctly. Notice in this triangle, all of the angles have one congruency dash. They are equiangular. Notice the rectangle. All four have one congruency dash. That means all the angles are equal. Notice in this pentagon, all of the angles have one. They don't mean, they're just talking about the polygon. All the angles inside this polygon are equal. So equiangular polygons means that all of their angles are equal. They are all equal. Next, we have a combination of the both. We have what is called a regular polygon. We have a regular polygon. And in a regular polygon, all of the angles and all of the sides are equal. So notice here in this quadrilateral that all of these sides are equal. And at the same time, all of its angles are equal. That is said to be a regular polygon. Same thing with this triangle here. Notice that all of its sides are equal and all of its angles are equal. And the same with this pentagon. All of the sides are equal and all of its angles are equal. And this is what we call a regular polygon. So we have equilateral polygons where all the sides are equal. We have equiangular polygons where just the angles are equal. And we have regular polygons where the angles and the sides are equal. All right, guys, now let's try some exercises.